All right, so problem number 4 is a centroid. Centroid of a composite body. A centroid of an object that is made up of smaller objects, smaller shapes. You won't have to do a function, but the centroid of a function is the integral of x tilde dx over integral dx, or dA, actually, sorry. Integral x tilde dA over integral dA function. The y location of the centroid, if this was a function, y tilde dA over integral dA. If it's a composite body, it's a summation of each of these x tilde A over summation of A. The y location is the summation of the y location of the centroid, A over summation of A. Remember, this x tilde is just the location of each of those centroids. So this is where we are. This is where we are. We're going to need to sum up each shape's area and each shape's location of their centroid and each shape's area. So this one, break it up into shapes, right? Break it up into shapes. I think we could break this up into that square, that rectangle, that triangle, maybe 3 objects, right? Break it up into 3 objects and just say, okay, I like to organize my thoughts by this. Let's write the section, 1, 2, 3. Go ahead and calculate its area. Go ahead and calculate its x tilde, and then go multiply x tilde times A. What is its y tilde? And the tilde is just the location of its individual shapes, centroid. Y tilde A, and then we're going to sum the y tilde A column, the x tilde A column, and the A column. And eventually, this is where we're headed. We're summation of x tilde A over summation of A divided, and then the y location is summation of y tilde A over summation of A. All right, it's really just a weighted average. It's really just a weighted average. Now, one thing that I'm going to do that I probably wouldn't do this, probably wouldn't suggest this, but I want to show y'all and make sure y'all can handle what if we have something, a shape, and we have some shape cut out of it. So instead of the 1, 2, 3 that I just had shown you, I'm going to say this is a solid 1, this is a 2, and then I'm going to subtract a 3, because sometimes you will need to do that. It'll make a lot more sense to think of these as solids, and then subtract out an area. What do you do when you subtract out an area? You just give it a negative area. Right, you just give it a negative area. So that's what I'm going to do, even though I probably wouldn't choose that. All right, so shape 1, what is its area? It's a 3 by 3, right, a 9 square foot. It's x tilde. All right, where's the centroid of a rectangle? Just right in the middle. So it's x tilde. Now, be careful. If axes are not drawn on there for you, you need to define your own axes. But if axes are drawn, which here they're drawn, the centroid of that would be at negative 1.5, right? It is 3 feet in width. Its centroid is negative 1.5. So multiplying those together, negative 13.5. Now, where's its y tilde? Its y tilde is positive 1.5, right? And so multiplying those together would be positive 13.5. All right, so that's that. That is this as if it was a solid rectangle. Section 2 is a triangle. The area of a triangle is 1/2 base times height, right? 4.5. All right, where is its centroid? Where's the centroid of a triangle? You should know it's 1/3 both directions. 1/3 both directions. And it's closer to the taller side. It's closer to the bottom than the top, right? Because the bottom is wider than the top. It's closer to the left than the right. Right, because the left is taller than the right. So the x location would be 1. It's 3 by 3. The y location, I guess, would also be 1. So this would be 4.5. This would be 4.5. All right, now let's cut out this 3. So let's give it a negative area of 1 by 2, so a negative 2. Where is its centroid? Where is its centroid? It's right there. So its x location it's halfway through. If this is 1 foot, then this is 0.5. Don't just plug in 0.5. It is 2.5, and it's negative. It's negative 2.5. Watch what happens. Even though this is a negative area, I'm multiplying these together, and I get a positive 5. All right, even though it's a negative area, it's a negative area, and it's a negative location of the centroid. Okay, now for the y tilde, this is 2 feet, so this is 1. Don't just tell me 1. It is 1 on top of 1, so it is 2. It's positive because it's in the positive y direction, and then multiply that together, negative 4. Okay, so add up all the areas, 11.5, add up all the x tilde a's, negative 4, add up all the y tilde a's, 14. So the x bar would be summation of x tilde a over summation of a. So this is negative 4 over 11.5, negative 0.348. The y bar, summation y tilde a over summation of a, 14 over 11.5, 1.22 feet. So you could write it like this, or you could say x bar, y bar is negative 0.348, 1.22, but I still need some units, feet. Feet. All right, so you can kind of choose different shapes, and I would have chosen different shapes, and maybe try this one. Try it. Try it by breaking up into a triangle, that rectangle, and that rectangle, 3 positive areas. You should still get exactly the same answers. Exactly the same answers. Okay? You know the triangle is the area is 1/2. The centroid is at 1/3. In case I give you some other ones, if I give you some other ones other than rectangles and triangles, I'll give you this formula sheet. So especially, circle makes sense, right? Rectangle makes sense. Triangle is 1/3. But this half circle and quarter circle, the area is 4r over 3 pi. Different from the arc. If you were trying to find the centroid of a line, you'd do that. But centroids of circles, the area, the location of a half circle and quarter circle is 4r over 3 pi. But that will be on this sheet that I'll give you if I give you a half circle or quarter circle. Okay? So be able to look at all the centroids that we've done in the book and these example tests. Know how to handle if you have to cut out an object, cut out an area from a larger shape, larger area.